Hello viewers, welcome to our second video on the nomenclature of cycloalkanes. In the first video I discussed a few examples about mono and disubstituted cycloalkanes. Today I'm going to tell you about how to name trisubstituted cycloalkanes with different substituents. You can follow the first video through the link in the description, and please watch this one till the end so as to get maximum information about how to name substituted cycloalkanes. So let's start our today's video. So I'm going to repeat the basic IUPAC rules that have to be followed in naming cycloalkanes. So the first rule is to count the number of carbon atoms in the ring. And when you have the number of carbon atoms, you just add the prefix before the name of the corresponding alkane, so it becomes a cycloalkane. If you have substituents present, so you have to identify the type and number of substituents present in the molecule. And then if it is a monosubstituted cycloalkane, you just write the name of the substituent before the parent name, and that is the complete name of the molecule. But if you have more than one substituents present, then indeed you have to number the carbon atoms in the ring. The numbering rules say that numbering will always start from a substituted carbon atom, and it will proceed in a direction so as to give lowest positions to all other substituents. So one of these substituted carbons will be your carbon number 1 in a multi-substituted cycloalkane. The positions and names of all the substituents are mentioned before the parent name, and you already know the rules when we were discussing the nomenclature of alkanes. You can also watch that video through the link in the description, that when we write the names of the substituents, they are written in alphabetical order. So we mention the position and the name of the substituent that comes first in the alphabetical order first, and followed by another substituent which comes later in the alphabetical order. Now if you have different substituents present on this cycloalkane ring, then numbering will always be done according to the positions of the substituents first. Now this rule means that you have to start numbering from one of the substituted carbon atoms and proceed in a direction so as to give lowest possible substituent position to all the substituents. That means that the sum of the positions of all the substituents must be lower. And I have already told you in the first part of the nomenclature of cycloalkanes how to calculate the sum and then keep the lowest sum for naming the cycloalkane. So you can watch that in first part of this video. And the numbering then proceeds in a direction so as to give the lowest positions to all the other substituents. So when you have different substituents, first you have to keep in mind the positions of all the substituents, right? If the positions are the same from all directions, you have different substituents and they are positioned in such a way on this cycloalkane ring that their positions are similar from all directions, or from any of the carbon atoms from which you start numbering, then you have to follow the alphabetical order. Now we have to follow these rules in naming some of the molecules that I have for you today as examples. So let's see some of the examples. So this is the first example, and I have mentioned here that rule number 5 will be followed. So you have more than one substituents on this cycloalkane ring, and you see here you have 3 substituents and all of them are similar. You have 3 bromo groups attached to this cyclohexane ring. Now to number the carbon atoms on this ring, you have to follow rule number 5. Numbering will always start from carbon number from a substituted carbon, and you have to proceed in a direction so as to give lowest possible positions to all the other substituents, or in other words, the sum of the positions of all the substituents have to be the lowest. Now, for example, we start from here. So this is your carbon number 1. Then if you proceed in this direction, the second bromine comes at carbon number 3, and the third bromine is at carbon number 5. So that makes it 5 plus 3 plus 1 is equal to 9. If you proceed in this direction, then we have this bromine at 1, this is at 3, and this one at 5. So again, the sum is 9. If you start from here and proceed in this direction, so 1, 3, 5. Again, it's equal to 9. You start from here and proceed in this direction, 1, 3, and 5. Again, it is 9. And same is the case for this bromine. You start from here, 1, 3, 5, 1, 3, 5. So it doesn't matter from which substituted carbon you start the numbering and in which direction you move, as long as the substituents are the same and their positions are same. Now it's up to you from which carbon atom, which substituted carbon atom you start and in which directions you move, because that will give you the same result. So we start from here and we move in this direction. So this bromine is at carbon number 1, the other is at 3, and the other is at 5. So it's a tri-bromo cyclohexane, and we have to mention the positions of all the bromine atoms. So it's a 1, 3, 5 tri for the 3 bromine atoms, bromo cyclohexane. So this is how you name multi-substituted cyclohexanes with similar substituents and similar positions from all directions. Now we have another example here in which again we have 3 substituents, but this time we have a different substituent. So it's a molecule with 2 bromine atoms and 1 chlorine atom attached on this cyclohexane rule. So to name this molecule, you have to go back and read rule number 7, 8, and 9. So we have different substituents. So when you have different substituents, first you have to look for the positions of all the substituents. So as I told you how to name this molecule, or how to start numbering and proceed the numbering in this molecule, we have to do that here again, right? So we start from here, this bromine atom. So this is at 1, 3, and 5, right? So in this direction, clockwise, the substituents are at 1, 3, and 5. Counterclockwise, again, they are at 1, 3, and 5. From this bromine atom, the substituents are at 1, 3, and 5 in this direction, 1, 3, and 5 in this direction. From chlorine atom, they are at 1, 3, and 5 in this direction, 1, 3, and 5 in this direction. So according to rule number 7, if you have different substituents, first you have to number the carbon atoms in the ring according to the positions. Now you saw that from any of these substituted carbon atoms and in any direction, the positions are the same. So the next rule is that if the positions are the same, then you have to follow alphabetical order. You have to start numbering from a substituted carbon atom that has a substituent that comes first in the alphabetical order. So we have 2 different substituents. These are bromine atoms and this is a chlorine atom. So bromine comes first in the alphabetical order. So we have to start numbering from a carbon atom that has bromine as a substituent. But again, we have 2 carbon atoms as which have bromine as substituents. So we can start numbering from here or here. That we will see in a moment. So if you start numbering from here and you proceed in this direction or in this direction, the positions of the substituents are same. If you start from here, again the positions are same from both sides, right? So you can start numbering from any of these 2 bromine substituted carbon atoms. So you can start from here or from here, it's up to you. Now the next question is in which direction we should move. Now for example, if you start from this carbon atom, should we move clockwise or anti-clockwise? So first you have to see the positions of the two other substituents. So from here, if you move clockwise, the other substituents are at 3 and 5. If you move counterclockwise, again they are at 3 and 5. Now the second thing you have to see is that whether you have similar or different substituents. So in this case we have two different substituents. So when we have different substituents, then we follow the alphabetical order. So you start from here and you move in a direction so as to give lowest locant or lowest position to that substituent which comes first in the alphabetical order. So if we move from here, the bromine that comes first in alphabetical order, then chlorine comes at 3 clockwise. So you start from here and you move clockwise towards bromine, it is at 3. But if you start from here and you move counterclockwise, then bromine is at 5. So this is the first point of difference in this molecule, right? So you start from here and you proceed clockwise so as to give lowest position to bromine because it comes first in the alphabetical order than chlorine. If you want to start from here, then you have to move in the direction of the second bromine. So if you start from here, then you have to move counterclockwise so as to give lowest position to this bromine, right? So you can start from here and proceed counterclockwise, or you start from here and proceed clockwise. So we start from here and we proceed clockwise so as to give lowest position to this bromine. This is at 3 and this is at 5. So we have 2 bromine atoms and 1 chlorine. While naming the molecule, you have to mention those substituents first which come first in the alphabetical order. So bromine comes first than chlorine. So it's a 1,3 dibromo 5-chloro cyclohexane. So when you want to write the names, you cannot mention chlorine first and bromine later, but you have to follow alphabetical order. Let's see another example. Now we have a tri-substituted cyclohexane again. Now we have slightly changed the positions of the three substituents. Again, we have 3 similar substituents, 3 bromine atoms attached to the cyclohexane ring. So you can follow rule number 5, and that suggests that if you have more than 1 substituents and they are similar, then you have to see the positions of all the 3 substituents, or take the sum of all the 3 substituents, positions of all the 3 substituents, and keep that sum which is the lowest, right? So we will try that in a moment. So you start from here and proceed clockwise. So the substituents are at 1, 3, 4. 1 plus 3 plus 4 is equal to 8. You start from here, 1, 4, and 5, and that is equal to 10, right? So you cannot keep 10, you can keep 8 instead, right? So if you start from here, you have to proceed clockwise. Then we start from here and proceed clockwise. So 1, 2, 4. 1 plus 2 plus 4 is equal to 7. Or you start from here and proceed anti-clockwise. So 1, 3, 6, and that is equal to 10. So you cannot keep 10 again. So if you start from here, you have to proceed in this direction. 1, 2, and 4. 1, 2, and 5, which is equal to 8, right? If you start from here, then the substituents are at 1, 2, and 4. So 1 plus 2 plus 4 is equal to 7. 1 plus 2 plus 4 is equal to 7. If you start from here and you proceed clockwise, then the substituents are at 1, 4, and 6, and that is equal to 10. So now you see from all the sums, 7 is the lowest, right? You started from here and you proceeded clockwise, 1, 3, and 4. This is equal to 8, so it's not the lowest. So if you start from here and you proceed in this direction, that is equal to 1 plus 3 plus 2 plus 4, and this is equal to 7. So 7 is the lowest that you can have. So we have to start numbering from this bromine and proceed in this direction. So this comes at first, this is at second, and this is at fourth. The sum is equal to 7, which is the lowest. So this is a 1, 2, 4 tribromocyclohexane. So if you have similar substituent with different positions, then you have to start numbering from a carbon atom and proceed in a direction so as to give lowest positions to all the substituents, or in other words, the sum of the positions of all the substituents is lower, the lowest. We have another example here, and for this you have to follow rule number 7. So we have 3 substituents, 2 are similar to each other and 1 is different, right? So according to the rules say that if you have more than 1 substituents, so first you have to look for the positions of all the 3 substituents. Alphabetical order comes later. So first you have to see from where you can get lowest positions to all, or you can give or assign lowest positions to all the substituents. So if you look at the positions of these 3 substituents, they look very much similar. The only difference is that here we have a chlorine, but that doesn't make any difference here, because first we have to look for the positions of the substituents, and because the positions are very much similar as in this molecule, so the numbering will also be similar to this molecule. So a different substituent here doesn't matter, because alphabetical order comes later than the lowest positions of the substituents when we talk about numbering and direction of the numbering. So we again will start from here, from this bromine, and then proceed in this direction, right? So this would be 1,4-dibromo 2-chloro-cyclohexane. Here we have another example. Now again you see we have a tri-substituted cyclohexane, and if you look at the substituents, again we have 2 bromines and 1 chlorine. The positions are very much similar as the first 2 examples, but we have shifted the positions of bromine and chlorine now. Now, rule number 7 suggests that first you have to start numbering from a substituted carbon and proceed in a direction so as to give lowest possible substituents to all the carbon, lowest possible positions to all the substituents. Alphabetical order comes later. So we start from here and proceed in this direction now. You don't have to worry about the alphabetical order of bromine and chlorine, because if you start from here, the substituents will be at lowest possible position. So again we start from here and proceed in this direction. So now this would be a 2,4-dibromo 1-chloro-cyclohexane. So you can have different substituents at different positions while naming cycloalkanes or numbering the cycloalkane ring. You have to keep in mind the positions first, and later you can of course see the alphabetical order in which they come, right? So this is how cycloalkanes are named. I hope it helped. Thank you for watching. See you later.